4 osoby. 4 osoby. Napiszę, jak już będę, wiesz, przed odliczaniem, że zaczynam. Raz, dwa, raz, dwa, raz, dwa. Słychać? Może za głośno? Tak, okej. Ja i tak jestem w słuchawkach, nie? To ja jestem, wiesz, jakby...
Tego nie... Tak.
Hello everyone, it's time to start. Welcome to today's Mythic 3 CRP training. First, please let me know over the WhatsApp if everything is well with the connection and if you can hear me and see me well. So I believe everything is well. My name is Łukasz Szymański. I am service engineer in International Service Department, and today I am an engineer who is leading this training. Of course, if you have any questions, you can ask questions during the training over the WhatsApp. The plan for the training is to start with the presentation first at PowerPoint. After the presentation, I will switch the camera to external one and I will show you the screen with the menu of the analyzer, and I will speak about the functions. So let's start with the presentation. Today I will speak only on Mythic 3 CRP analyzer. Mythic X training is cancelled for today. The project is not finished yet, will be continued, and we plan the training from this unit next year. We will inform you about the planning of the training in next year. So before I will start speak about the analyzer, I would like to introduce our team. Here you can find our email address, support@orphi-medical.com. In case of any technical issues, you can contact us using this email address. This email address includes 5 persons, 5 engineers. As you can see, first on the list is Michel Legrand. He is a director of International Service Department. He works in Geneva, in Switzerland. Apart from him, we have 4 engineers in our team: Jan Staniak, Michał Szubartowski, Maciej Greszta, and me, Łukasz Szymański, who is leading this training. Here you can find our other contacts which can be useful for you. If you have any problem with quality control or calibrator or reagent, I mean contamination, damage of the reagent, you can contact directly with Michał Leśniewski, who is specialist in the QC department. Also, you can find our main address to customer service department. Actually, in case of customer service, we have a dedicated person to each region or country, each region or country. Here you can find our portfolio, current portfolio of analyzer, which we currently have in our offer. And starting from Mythic 18, this is a 3-diff unit. Mythic 22 OT is a 5-diff chematology unit. Mythic 22 AL is also 5-diff chematology unit, but with sampler. Mythic 60 is a new version of Mythic 22 OT, and it is also 5-diff instrument. Mythic 18 Vet is a veterinary version of Mythic 18. This is a very similar instrument. The difference is in the software and in the reagents. Mythic 18 Vet uses a reagent pack, which is installed under the left cover of the analyzer. And in our offer, we have also 5-diff instrument dedicated to veterinary. This is Mythic 5 Vet Pro. Mythic X, as I mentioned before, this project is not finished yet and will be continued next year. Mythic 3 CRP, which we will be focused today, is one of our new product. Mythic 70 is a 5-diff instrument with sampler. It is very similar analyzer to Mythic 60. The hydraulic structure and hardware components are very similar, but the analyzer is equipped with sampler. This is agenda for this day. First, I will start from the introduction. Next, I will speak about 3D technology. I will show you new features in Mythic 3 CRP. And also I will show you how to perform the first installation of this unit. So let's start from the introduction. Mythic 3 CRP is a chematology analyzer with additional CRP module. So we can say we have two solutions in one box. We can measure, we can perform a measurement in CBC 3D mode, on CRP mode only, or both CBC 3D plus CRP. Later I will work with the software and I will show you how to program it. This unit has also predilution mode. On this slide you can see some basic parameters of this device. Here you can see all reportable parameters by this device. Reagents. We have two sets of reagents. One is a reagent for hematology part of unit, and the second set of reagent is for CRP module. And for hematology, we have a diluent and lyse, which are connected with the analyzer, and cleaner. Cleaner is an external bottle. It's used only when a soaking procedure is activated to cleaning. So it is necessary to put it to the needle. Reagent for CRP. We have a CRP lyse reagent and CRP reagent. This one is installed in the refrigerator. It should be stored in low temperature from 2 to 8 degrees Celsius. So this unit is, this analyzer is equipped with a refrigerator. Controls. Also we have controls for hematology, 3D part of the instrument, and controls only for CRP mode. For hematology part of unit, we have Mythic Met3CRP normal box, which you can find only normal label. And we have a box with a low, normal, plus high level. Calibrator for the chematology part of unit is Met3CRP Cal. It is one label of calibrator. Controls for CRP mode. It includes 3 labels of controls, label low, normal, and high in one box, and calibrators for CRP. We have 6 labels of calibrators with different concentrations. So the calibration curve for CRP is spline, and that's why we need 6 labels of calibrators. Later, I will show you a table with detailed information about the control and calibrators. Sample volume is 20 microliter, also in pre-dilution mode. Throughput. In CBC 3D mode, the throughput is 60 samples per hour. In CBC 3D plus CRP mode, we have 45 samples per hour. And in CRP mode, we have also 45 samples per hour. This is an open vial instrument. There is no version with autoloader, so it's necessary to mix the blood manually and put to the needle. Next, you have see the information about background range. If one of these values is exceeded, the analyzer will give you an alarm. Next, the information about the carryover and precision. You can find this information in the user manual. Data storage is up to 50,000 results with alarms and histograms. This device should work in a temperature from 18 to 13 degrees Celsius. Ja już napisałem, że wracamy zaraz z powrotem. So sorry for the technical problems. I had a problem with connection. I hope right now everything is well. So maybe I will repeat the information from the technology. We have 3 measurement chamber in this unit: WBC channel, RBC PLT channel, and CRP. In WBC chamber, the total number of WBC is measured by impedance method. Also 3D parameters are measured, I mean lymphocyte, mid cell size, and granulocytes. Hemoglobin measured is also in WBC chamber measured by colorimetric method. The second channel, LBC PLT, RBCs and PLTs are measured by impedance method. And CRP channel. CRPs are measurement by latex and handset scattering immunoturbidimetry method. Later I will speak in details about this method. So as a reminder, there is you can see some vial with human blood. This is just a reminder for you. At the bottom we have erythrocytes, and it is around 45% of total blood. Above the erythrocytes there is a buffy coat leukocytes and platelets, and it is less than 1% of total blood. And plasma, it is around 55% of total blood. On this slide you can see how the cells look like, what is the size of the cells and quantity in normal human blood, and what is the function single cell. And start from WBC. You can see the picture. The size of the cells is from 6 to 10 micrometer. Quantity in normal human blood is from 4 to 11,000 per microliter. Function, it is responsible for immune system, defending body against infectious disease and foreign materials. Next, RBC, the size of the cells is 7.5 micrometer. Quantity in normal human blood from 4.5 to 5.5 million per microliter. It contains hemoglobin responsible for oxygen transport. And PLTs, size from 2 to 4 micrometer. Quantity from 150 to 400,000 per microliter. And it is responsible for formation of blood clots. 3D measurement principles. This is a 3D technology. What we can see here. From the whole blood, a small amount of sample is aspirated and dispensed to WBC chamber first. And in this analyzer, in this unit, in Mythic 3 CRP, this is a 20 microliter blood. So it is dispensed to the WBC chamber. Next, the diluent is added, and the first dilution is performed. From the first dilution, the needle aspirates liquid from the WBC chamber and aspirate to RBC chamber. In RBC chamber, diluent is added and the second dilution is performed. In the meantime, in WBC chamber, lyse is added to WBC and HGB dilution. RBCs are destroyed and hemoglobin is released and available for measurement. Coulter principle, what we can see here. There is a Coulter principle in impedance method using in WBC and RBC channel. There is a chamber with aperture. In the chamber, we have a front electrode, and behind the aperture is a rear electrode. And between those two electrodes, we have a stable current during the measurement. There is a dilution blood in the chamber. It is a liquid with single cells inside the chamber. And when we put vacuum here, the single cells are going through the aperture. And we can consider that the single cells we can consider the cells are small particles which are not conducting the electricity. And that's why when this cell is going through the aperture, we can detect a change of impedance in this detection area. And we have a voltage pulse here. Because we still have the stable current between those electrodes, front and rear. The voltage pulse has a proportional height to the cell volume. And this variation generates an electrical pulse, which can be further amplified and analyzed and lead to a volume size distribution diagram. What is important here? The aperture diameter size for WBC channel is 100 micrometer, and for the RBC channel, the aperture diameter is 70 micrometer. This is a common solution in many 3D chematology analyzers. This is a picture where you can see how these components look like in a Mythic 3CRP. This is an exact diagram of Mythic 3CRP. On the previous slide, there was a general explanation of impedance method. But in case of 3CRP, this is our aperture with a diameter for WBC channel 100 micrometer here, for the RBC 70 micrometer. This is an electrode in the front tank. Here we have a rear chamber electrode, and we put vacuum to this tube. And the single cells liquid with a dilution with a single cells is going through the aperture. So now I will try to explain how the histogram is generated. The analyzer counts every single cell. This is the size of the cell in time. And if we will take an oscilloscope, we will receive information about counted cells in time, as you can see on this graph. This is the first step, but this is not a histogram yet. In the next step, electronic components of the analyzer transforms this signal based on height of a single pulse during cells counting. And then the histogram is generated. A histogram is the relation between cell size and cells numbers. On the x-axis we have a cell size or cell volume. On the y-axis there is a cells numbers. For example, we have a WBC histogram. In this area we have a lymphocyte because they are the smallest cells and they are at the beginning of the x-axis. Next are the mid-cells, mid-side cells with the monocyte and granulocyte in the end. RBC histogram, similar like WBC, the cells volume and cell numbers. Based on RBC histogram, MCV and RDW are measured, are calculated, and the rest of the parameters in the RBC channel, and histogram for PLT. Colorimetric method. Hemoglobin is measured using colorimetric method. There is a light source here, LED lamp. We use 525 nanometer wavelength. Next, there is a solution, a liquid in WBC chamber, filter, and photodiode as a detector collecting the signal. What is important here? First, it is necessary to measure blank photocurrent. It is measured at the beginning of the cycle before blood dilution in WBC chamber. The blank of colorless diluent is measured then. When the sample photocurrent is measured after lyse adding to WBC chamber and mixing. And when we have these two values, the hemoglobin is calculated by this equation. So the same method is using in many hematology analyzers. CRP channel and immunoturbidimetry principle. I will try to explain right now. To measure the CRP concentration, we use a separate channel. There is a CRP chamber inside. Stable temperature is provided by the heater, and we have 37 degrees inside the chamber. First, from the hydraulic point of view, analyzer performs a dilution with diluent and sample blood in the chamber. Next, R1 reagent is added to dissolved RBCs. We don't want to have RBC in this channel during the measurement. Next, CRP reagent 2 is added to adsorb CRP antibodies on latex particles. And there is a light source here, emitter. This is a red laser with 625 nanometer wavelength. And the receiver. Receiver is collecting scattered light. We are measuring the scattered light, not transmitted light. That's why this is the name of the method. The light scatters as it means antigen CRP antibody complex. And the analyzer receives scattered light by phototube and transform it into electronic signal after amplifying the light signal. And when we compare it with the voltage produced by background light before the sample is added to CRP, the CRP concentration can be produced. So this is similar like for the hemoglobin channel. First, we measure a background, and next, after performing a correct dilution in the CRP chamber, we measure the scattered light by CRP antibodies. The scattered light intensity is in direct proportion to the amount of complex. So I hope it's clear for you. You can also find information about the process in the user manual. This is a real picture of the chamber, but not all is visible in the analyzer because the chamber is covered in foam. We have a foam here to keep the stable temperature. And there is a lamp emitter, red laser with 625 nanometer wavelength. Here is the receiver displays and connectors for R1 reagent, which is lyse reagent in CRP channel. R2 reagent is this is a latex particles and the diluent. On this slide, you can find some information about the QC and calibrators, like shelf life after opening, storage conditions, and composition. According to calibrator to chematology part, we use MED3CRP cal. It is possible to purchase with one vial, two vials, and three vials inside the box. That's why you can see those three positions here. For the CRP module, we use Mythic CRP calibrators. This is the correct name. And there is 6 vial inside the box. The calibration curve for CRP is spline, and it is necessary to use 6 calibrators with different concentrations. Below, information about the controls. For a chematology part of unit, we use MED3CRP controls. Those for position, but we have it is possible to purchase with 3 vial inside with low level, normal level, and high level. And also it is possible to order only normal level with 1 vial inside, with 2 vial inside the box, and with 3 vials inside the box. Those 3 position includes only normal level. For CRP module, we have Mythic CRP controls, and there is one options here. We have a 3 vial inside with low level, 1 normal level, and 1 high level. So here you have a picture how it is look like, a picture of the labels for MED3CRP cal. and Mythic 3 CRP controls. And for the CRP part of unit, for CRP channel, we have a CRP calibrator, 6 labels here, and 3 labels of controls. So it is necessary to purchase 2 types of calibrators to this unit and 2 types of controls. One for a chematology part of unit and one for CRP module. You can find the picture, the table with reagent, information with reagent for Mythic 3 CRP. And there is a different volume for each reagent, for each bottle. For diluent, we have a 20-liter bottle and 10-liter bottle. For rice, 500 milliliter bottle and 200 milliliter bottle. These are for the chematology part of unit. CRP lice is in 75 milliliter bottle and 200 milliliter bottle, and CRP R2 reagent is in 75 milliliter bottle and 45 milliliter bottle. Cleaner is in 50 milliliter bottle. It's up to you which volume is better for you. You can calculate by yourself or ask our product manager. On this slide, you can see a picture with reported parameters by this device. And here there is a total number of WBC and 3D parameters in percentage and in absolute result, RBCs, and all the other parameters from RBC and PRT channel and a CRP. On the right side, there is an area for histograms, WBC histogram, RBC, and PLT. And between, there is an area reserved for flags and errors. So right now I would like to talk about the first installation of this device. So first point is unpacking from the box and remove protection inside of the analyzer. Very important. Here there is a place where you can grab and carry the analyzer. It's marked here. Inside of the unit, there are 2 clips on the belts to remove. One on the belt in horizontal movement. This is a horizontal movement of the sampling module. And one on the belt in vertical movement of the needle. Here. These are protections during the shipment to avoid needle damage. Next, it's necessary to check the box with the impedance channel. Behind the right door, you can see the box, and there are RBC chamber inside and WBC chamber inside, and it is necessary to connect if everything is well behind this box. If all tubes are connected well. Next, on the back side of the analyzer, we have a power socket. Before you turn on the unit, connect all reagents and waste tube according to color of the tube. Behind the left door of the analyzer, it is a space to install of the reagents for CRP mode. CRP reagent, this is the small bottle, is installed in the refrigerator. There is a refrigerator this place. And CRP lies here. If you connect all reagents and waste tank, you can turn on the device. There are two switches. Main switch is on the rear panel of the analyzer above the power socket. When it is turned on, only refrigerator is active. The second switch is on the left panel of the analyzer. You can see it on this place. When it is turned on, this is the exact switch of the analyzing part of unit. This one is only for refrigerator, and it is turned on all the time because the CRP reagent is installed in the refrigerator. So I can see some questions from your side. Maybe let's take a short 10-minute break, and during the break I will answer to your question, and we will continue after the short break. So I'm back again. Let's continue the training. So I hope the quality of the video is okay. So remember to remove the clips from the bells. It's very important before you turn on the device the first time. So when the analyzer is turned on, it is possible to log in as a admin user or as a service. During the first installation, I suggest you to use service user and password, which give you an access to service option needed in the installation. And after you log in first time, Analyzer automatically starts with Fluidics initialization process. Then all reagents tube starts priming. On the end of this cycle, the background measure is performed, so it takes a few minutes. When the cycle is finished, you will see the results of background, and everything should be in the correct range. If a background test is failed and some errors appears, in this place you can go to service, comprehensive device maintenance, and perform fluidics initialization twice. Sometimes when the device is new, it is necessary to prime a few times to remove air bubbles from the tubes well. But generally, after you turn on this device for the first time, the analyzer starts automatical priming process. So that's why don't forget to connect all the reagent tubes before you turn on this device. You can see the table with acceptable background results. If one of these values is exceeded, the analyzer will give you an error message. The next step during the installation, when the initialization is finished with positive results, the backgrounds are okay. Then go to service, replace reagent, and use code RFID card for all reagents to input correct information. So as I mentioned it before, each reagent has its own RFID card. It is a closed system of the reagent. How to input information about reagent? We have a reagent management window. So we need to choose the reagent from the list. Click Setup. Then additional window appear, and you need to just place a correct card to the RFID reader and perform the same procedure to all reagents to input all informations correctly. Later, when I will work with the software, I will show you how to do that. It is possible to set purchase reminder, as you can see in this window. How it works? If you put 5 liters, for example, for diluent, the analyzer will remind you that diluent is almost empty, and you have information that you have to purchase a new one. The same in case of other reagents. If you put some volumes here, when this volume is reached by the analyzer, you will see a reminder message. Then the user knows when to purchase a reagent. It can be useful, but actually it's up to you if you want to use it. If you put 0 value here, this option is not active. So the next step during the installation is Mythic 3CRP cleaner soak procedure performing. Actually, we recommend to do it even if the analyzer is new. To do that, enter the service maintenance, as you can see here, and choose the Mythic 3CRP cleaner soak. Then additional window appear and the analyzer will inform you to put the cleaner to the sampling needle. And you need to press aspirate key, and this is an automatic process. It will take a few minutes. The next step, 2-3 minutes after startup, we suggest you to open the small left door. Put your hand on the heatsink of the reagent refrigerator. Here is the heatsink. And check if the fan is running normally. If you can feel the wind, that means the refrigerator is working normally. Actually, there is a peltier inside in this place. One side is cool, the second is hot, and needed to be cooled by heatsink and fan. Also, you can control the refrigeration, the temperature of refrigerator in the software. Later, I will show you. Verify if the software version is the last software version. Currently on our website there is no software to this unit, but in the future will be added. We recommend to upgrade software version every unit during the installation to the latest version. So the software version you can find on our website, coremediagnostic.com. It is necessary to use your login and password. Without the login and password, you cannot download the software. Next point is the voltage and current checking. And what is important here, the hemoglobin blank voltage. Hemoglobin blank voltage and SP scattering blank voltage. This is important for us during the installation. This value needs to be adjusted when it's exceeded the range. Normally, it is not need to adjust, but you need to check these voltages because sometimes it can happen to some units. How to adjust it if necessary? So you have to go to service, meterage, and gain settings in the setup interface. And then this window appear in the analyzer. And so what is important for us, check whether the hemoglobin background voltage is within the range 4.5 volts plus minus 0.3. To adjust, you can use plus or minus to change the gain in this field. And in the real time, you will see currently voltage of hemoglobin. When the value is around 4.5, tap Apply or OK to apply changes. And the next adjustment of CRP scattering background voltage. In the same window, check whether the CRP background voltage is within the range. Should be 0 plus minus 0.3 volts. You need to see value around 0 in this place. The same you can adjust using minus or plus, and in a real time you will see some changes here. After the adjustment process, tap OK to apply changes. Position needle adjustment. This is the next step to check, to inspect during the installation. Normally, it is not necessary to adjust the needle, but we suggest you to perform the checking procedure. To do that, you need to go Service, Debug, and Position Adjustment. And what is important here? You just need to check if the end of the needle, the tip of the needle is aligned with the bottom of the swab. This part, this white part, is called swab in analyzer, and the tip of the needle should be aligned with the bottom of the swab. This is a part responsible for external cleaning of the needle. To perform the checking procedure, just tab Check in this place and verify. If it is necessary to adjust, you need to press Start key, and then up and down key will be active. So you can use these buttons up and down to manually adjust the position of the needle. And apply changes. To apply changes, press OK button. And then repeat the checking procedure and verify if the tip of the needle is aligned with the bottom of the swab. As I told you previously, normally it is not necessary to adjust. You need to just check this step. So next, we suggest you to perform background range test. It is possible to do that. Click Performance Background to enter to the background interface. Next, select the whole blood. And perform at least 3 analyses. Then some results appear in this window. To perform the analysis, press Aspirate key of the analyzer, and then some results will appear in this window. And in this place, you will see the conclusion, the result, if it is pass or fail. If all the values are within the range, the test will be passed. If one of these values will exceed the range, you can see the fail conclusion here. So when the background results are not correct, you just need to prime reagent a few times, because when the unit is running first time, sometimes we have air bubbles inside the tubes and should be primed well, and you need to repeat this test again. CRP gain calibration. Actually, at this point, we start with the calibration process of the analyzer. And the first step during this process is performing CRP gain calibration. In this place, we are not use CRP calibrators yet. We are use background sample or blank sample to perform analysis, to perform this procedure. We need to run 6 measurements of blank sample to check the CRP reagent blank. When you are in this menu, you need to press start button 6 times without any calibrator and verify if the conclusion here is pass or fail. If it is fail, verify the CRP blank voltage again. It's necessary to verify the CRP blank voltage if you can see 0 value here. Then the next reason why it is failed could be that the CRP chamber could be dirty, or hydraulic system is not primed well, or something is wrong with the CRP reagent. It is important to perform this procedure, this calibration, before you start calibration with calibrators. Remember that. When it is passed, press save button and go to the next step. It will take you around 10 minutes to perform this whole process. If conclusion is passive, if everything is okay. So next we need to perform CRP module calibration using CRP calibrators. 6 vials, 6 different labels of calibrators. But please note in this place that it is necessary to use admin login before you start. If you are logged as a service before, right now from this place you should log as an admin user. Because if you are logged in as a service, you will modify the factory gains coefficients, and it is not recommended. We don't want to do that, to modify the factory gains. That's why log as an admin user to perform calibration with calibrators. As when you are logging as an admin, you will modify the user gain, not the factory gain, and this is the correct way. So from this place, we can relog the instrument as an admin user. So for the CRP, there is a 6-point calibration curve. For the CRP, there is a 6-point calibration curve. Spline. You can perform. You have to perform even 6 repeats, but actually it is necessary. It is 2 repeats are enough for each calibrator. So what you should do in this window? Choose the calibrator 1, input the target, the concentration from the assay sheet, and perform at least 2 measurements for each calibrator, for each of 6 calibrators. You can even perform 6 measurements, but it will take you a lot of time. From my experience, we know that 2 repeats are enough. 2 repeats for each calibrator. If you perform the 2 repeats for each calibrator, then calculate button will be active. So click calculate and verify the calibration curve. And next press save button to apply the calibration. By the way, don't use recalibrate and clear button when you are performing the calibration if you don't want to lose the results in this window. When you press recalibrate or clear, you will lose the previous results. So I think everything is clear here. And it is time to start calibration of 3D part of instrument. You have to use Mythic cal to perform this process. Similar like for a CRP module, it is necessary to use admin login before you start. Input the lot number of your calibrator here, the expiry date, and input the targets from assay sheets from those 5 parameters. So sorry for the next problem for my side. I'm back again. Yeah, I know that you had a problem with the connection, but I think it is right now it's okay. Sorry for this kind of problem. This is a connection with the internet, the Ethernet issue. So I will repeat from the calibration from the Mythic CRP cal calibration because I am not sure if you hear. So to perform the Mythic 3CRP calibration of the chematology part of unit, you have to use Mythic to perform this process. This is a calibration of impedance channel. And similar, like a calibration for CRP mode, it's necessary to use admin login before you start. So input the lot number here, choose the expiry date, and input all targets from these 5 parameters from the assay sheets. Assay sheets you can find in the box or on our website, coremediagnostic.com. In this window, you need to perform at least 5 measurements. Then analyzer will calculate the new coefficient calibration. And when you have a repeatability result here, you can save the new calibration coefficient. Just press save. We have some recommendations regarding using Med3CRP-Cal. Before use, it should be removed from the refrigerator and warm to room temperature. Mix gently in the meantime. So to perform the calibration in this window, you have to put the calibrator vial with calibrator to the needle and press aspirate key 5 times. It is not necessary to do 10 repeats. 5 is enough. From this result, you have to select at least 5 repeats, and then new calibration coefficient will be calculated. Now I will speak about QC. There are 3 ways to input QC information to the software. First step is a manual. User can manually input QC data. To do that, click QC window and next QC settings. Next, press New button. Then additional window appear, and you can manually input targets and limits. With lot numbers for the control, expiry date, and QC mode. Next, click Save button to apply changes. The second method is importing file using QR code. To do that, here you can see the import key. So if you want to input information using QR code, press import key. Then additional window appear. Select file type QR code and scan the QR code. Remember to hold the 2D barcode scanner close to the QR code that contains the QC information. QR code you can find on the assay sheets. It is available in the assay sheets for the 3 levels of controls. When you scan, just press OK twice to apply changes. After confirming the QC information with the assay sheet, click Save to apply changes. And it is possible the third method is import QC information from QC file. Select In the import window, select the file here and connect the USB stick to the USB socket on the right side of the analyzer. And the additional window appear. And then you can choose the correct level of control which you want to import. You can find this file on our website, coremate-diagnostic.com. When you copy to USB stick, should be located, these all files should be located in the main catalog of USB stick. You don't need to put into any folder, just to main catalog. Then analyzer will see those files correctly. So select the correct file, tap open, click OK. To perform the QC analysis, select QC and QC analysis. And you need to choose the correct file number from the list here and press aspirate key when you want to perform the QC analysis. And in the same window, you will see the result with histograms. You can review the results of LJ graph as per the following steps. When you choose the QC graph, you will see the results with a low range, high range, and the middle value. You can scroll it to see the results for the all parameters. If you want to delay the QC files, which will not be used anymore, please take the following steps. QC settings. And window, you can see a delete key. So use this key if you want to delete the file number. The second option to delete, if you want to delete QC results of a specified file, enter the QC interface, click QC settings, select the QC file in which the QC results are expected to be deleted, and click clear. There is a second one, but not visible here. Later I will show you in the software. If you need to perform repeatability tests, it is possible to do that using control blot or fresh human blot. Select whole blot mode in the sample analysis interface to run the normal control blot or human blot no less than 10 times consequently. To check the counting result above in the review interface, there is a possibility to select those results, should be minimum 10 repeats, and click CV button to calculate and repeatability and make sure that they are within the range. I will show you later in the analyzer in the software how to perform it. In this part of training, I will speak about settings, fluidic systems, hardware, and and the last one, maintenance. So let's start with the settings. Settings, correct date and time. Actually, I have nothing to add. It's quite clear. I will skip this. There is an option to activate soft keyboard to input data into software. If soft keyboard is off, you need to use an external USB keyboard. You can find it accessory of the analyzer. Print settings. If the customer wants to use print function, confirm the printer supports PCL protocol and operates normally. For the external printer, we use PCL3 and PCL6 drivers. So in this window, you can choose the printer driver. If you are using an external, should be automatic. Should be choose check automatically in this window. Then analyzer will automatically find a driver to printer. if you want to activate a built-in thermal printer, from this list, from printer driver, you should choose built-in printer. Then the built-in printer will be active. So you can set the format settings here, auto print settings. It's up to you, and you can select or disable or enable the printing options. What you want to see on the result, on the printout, you can define this window. If you need, you can set the lab information. User management. Administrator has the access to set the account information of general users and other administrators. Common users can only browse the user list and change their own password. There is an option to add new users account in this window. You can add new user, define the new password for this user, or delete user account in place. In auto maintenance settings, you can set auto sleep waiting time. This field from 15 minutes to 120 minutes. Auto sleep waiting time. After this time, analyzer will go to sleep mode. Define auto soaking time. You to correct the correct hour. It's up to you. And wait time. It means that if you will put here 10 minutes, the soaking time will be 10 minutes. If you put 20 values here, the soaking time will be 20 minutes. ERP reagent tube auto clean waiting may be set from 24 hours to 72 hours. Parameter settings. There is an option to modify internal data dictionary. You can modify or add new departments, submitters, patient types, and other parameters here. When you want to add new item to data dictionary, use new button here. You can also modify, add or edit already existed profile. It's up to you if you need this option, but it is possible to do that in the software. You can modify the parameter units. You can select the unit system if you want to use custom China, international, USA. It's up to you. You can also modify units if you want to see the results per liter, per microliter. It's up to you. It is possible to edit and modify the reference range for those 4 groups: general, woman, man, child. If needed, you can create a new group and set the reference range. You can edit the flag rules also. Actually, we don't recommend you to change in this window, but some users may need this option, so it is possible to edit flag rules for all these flags. You can, when you press edit, then additional window appear and you can modify the value in this window. You can also recover the default settings. There is a switch to do that, the button. Host network. On the host communication screen, you can set the network information of the analyzer to enable its network connection. When you want to send a result to LIS, it should be defined in this place. So in the LIS communication interface, you can set the communication between the system and LIS, including network settings, protocol settings, and transmission mode. It is possible to choose transmission settings. You can use one-directional communication or bidirectional communication. It's up to you. And other settings should be set by IT people. So this is all from the settings. When I will switch the camera to external later, I will also show all these options in the menu. Now I will speak about the hydraulic system. So maybe let's do a short 10-minute break, and I will back to you in 10 minutes. Then we will continue. So let's continue the training. Now I will speak about hydraulic system. I will show you what types of valves, pumps, and syringes are installed in this unit in the analyzer. Also, I will show you videos from the analyzer measurement cycle. Oh, in this picture, you can see RFID logo. As I told you previously, it's above the printer, so when you want to input new reagent information, you can close the RFID card to this place. Let's start with the valves. There are 4 types of valves in this unit. Large valve, this one is called like a large valve, as a 2-way and 3-way valve. There is a 2-way version of large valve and 3-way version of this valve, marked with the L letter in brackets. And a small one also as a 2-way version and in the 3-way version, marked as a S in brackets. In total, there are 18 valves from numbers from 1 to 18. Pumps. We have 2 types of pumps in this unit. One is a air pump. This one is an air pump. And the second, liquid pump. Here, the liquid membrane pump. Air pump is responsible for generating positive pressure. Liquid pump is a membrane and it discharges waste and generates negative pressure in the chambers, in the pressure chambers. In case of a syringe in a hydraulic system, we have five syringes. On this picture, you can see on this the photos of hydraulic parts of syringes. Number 1 is a sample syringe. The volume is 100 microliter. The second syringe, CRP diluent syringe, 2.5 milliliter volume. CRP lyse syringe, also 2.5 milliliter volume. The fourth syringe is a lyse syringe to 3D part of unit. This one was to CRP mode unit lyse syringe, and this one is to 3D part of unit, to the hematology part of unit. And the volume of this syringe is 2.5 milliliter. And diluent syringe has a 10 milliliter volume. You can see the photos of other hydraulic parts like sample probe, swab. Swab, it is something like a rinsing head. Is responsible for external cleaning of the needle. Pressure chamber. Actually, we have 2 pressure chambers in this unit. One is a positive pressure chamber, and second is a negative pressure chamber. Counting chambers. This one is WBC chamber and RBC chamber. It is located in the metal box on the right side of the analyzer. Next, you can see the CRP chamber. CRP chamber, as I mentioned it before, it is not visible because it is covered by the foam to keep the stable temperature. Next, we have a CRP reagent heating chamber. On the left side of the CRP chamber, we have a CRP reagent heating chamber and a diluent heating chamber. On this slide, you can see the overview of hydraulic diagram. So I start from CRP chamber. In this place, there is a CRP chamber. This one is WBC. This one RBC chamber. Pumps. PP01 is a liquid pump, liquid membrane pump. PP02 is a pressure pump. And in this place, you can see the positive pressure chamber and negative pressure chamber. Something about the syringe. This is a lyse syringe module, and we have a lyse syringe. In this place, as I told you, 2.5 milliliter. Next to this lyse syringe is diluent syringe, and it has a 10 milliliter volume. In this place, you can see CRP diluent syringe, sampling syringe, 100 microliter, and lyse and the syringe which is responsible to dispensation reagents in CRP mode. The CRP lyse syringe and CRP reagent 2 also is dispensed by this syringe. This is a sample probe, then the needle with swab. Okay, let's continue. We have a bubble sensors on each line of reagent. When the tube is empty, the analyzer will show you an alarm. In this place, we have a diluent heater here, and under the chambers, under the RBC chamber, we have a isolation chamber. The same in case of WBC. We have an isolation chamber under the this measurement chamber. This hydraulic system is not much advanced. The principle of the hydraulic system in CBC 3D plus CRP mode. So we have a 20 microliter blood. First is this dispensed to CRP measurement module, where R1, which is CRP lyse, and R2 CRP reagent is added. This is a hydraulic principle. Next, have a discarding blood and dispensing to WBC bath, where diluent and lyse is added. Next, the dilution to RBC chamber, where only diluent is added. And at the end, the blood is discarding from the needle. So now I would like to show you how it is look like on the video. I have 2 videos. First is in the CBC 3D plus CRP mode. So please take a look at the video now. So first the needle is going to CRP chamber. Next WBC chamber. The dilution is performed. First dilution, first bubble mixing. Now the needle aspirates amount of liquid and dispense to RBC chamber, and the second dilution is performed. In the meantime, the lyse is added to WBC chamber, and right now there is a counting cycle. The vacuum is generated by liquid pump. Now is finished. So please take a look at the second video, and now it is only in 3D mode without CRP mode. So the needle is going directly to WBC chamber first. First dilution is performed. And next to RBC chamber. So this cycle 3D only is a little bit shorter and takes around 1 minute. The whole cycle 3D plus CRP, it takes around 1 minute 30 seconds. On this slide, you can see a description about WBC and HGB channel, which method are used, what parameters are measured, and what reagents are used to perform the analysis. And I would like to show you on the diagram how it is looks like. In this diagram, you can see fluidic flow for the WBC chamber for diluent, lyse, and sample. So right now we are focusing only on WBC chamber now. So first, diluent is added by this syringe and going to the diluent heater. To the WBC chamber. So sample is added by 100 microliter syringe by the needle to WBC chamber, and lyse is added by this syringe 2.5 milliliter. You can see what is the correct fluidic flow, which valve are need to be working. In the meantime, the pump PP02, the pressure pump starts working. And then there is a mixing. By air bubble in the WBC chamber. So similar for the RBC and PLT channel. Let's go to the diagram. Diluent is added by this syringe, 10 milliliter syringe. The valve LV12 is switching to this position, and diluent is transferred directly to RBC chamber. Diluted sample from WBC valve is added by 100 microliter syringe by the needle. And next, PP02 starts working, and we have there is a mixing bubble in the RBC chamber. So now the measurement cycle for WBC and RBC and PLT, the counting cycle and draining cycle. So the PP01 starts working and correct vacuum is generated in the negative pressure chamber, and dilution with cells are going through the apertures in both chambers at the same time. After counting cycle, the chamber is drying also by PP01 pump. So once again, PP01 starts working, the negative pressure chamber, and it generates the negative pressure in the negative pressure chambers, and the liquid from both chambers at the same times. The liquid with cells is going through the apertures. And the next, the both chambers are drying by the same pump. After the counting and drying cycle, there is a cleaning. So diluent is added by this 10 milliliter syringe to both chambers and through the both apertures. Next, everything is discharged to the waste tank. The pump PP01 start working, and the both chambers are draining from the diluent, and everything is going to waste. The chambers are primed again with diluent, and it is ready to the next measurement. How it is look like in a CRP channel. In this channel, we use diluent CRP R1, which is CRP lyse reagent, CRP R2, latex particles. So let's go to the diagram. The first CRP reagent 1 is added to CRP chamber by 2.5 milliliter syringe. You can observe this line here. Next sample is added by 100 microliter syringe through the needle to the CRP chamber. Next, CRP reagent 2 is added by the same 2.5 milliliter syringe. And dilution is mixed by diluent syringe in this case. This is the cycle from CRP chamber. When dilution is prepared, the red laser is active in the module, and analyzer is measuring the scattered light of CRP antibody adsorbed on latex particles. Next, the CRP chamber is cleaning by diluent syringe. Liquid after the cleaning goes to the waste tank. PP01 pump starts working. Next, the CRP chamber is primed with diluent again, and it is ready to next measurement. So this diagram you can find also in the service manual with the fluidics flow. I think it is not complicated, and I hope it is clear for you. Now I will speak about the hardware system shortly. You can see the overview of hardware system. We have 5 electronic boards in this unit. And this is a main control panel. This is just a structure. Main control panel is a main board. Have an indicator light panel. LCD is a green interface. Reagent sealing panel. Reagent testing panel. CRP laser drive panel, which is responsible for control CRP model. A reagent refrigerating panel. And other external connecting devices in the analyzer like valves, pumps, motors, sensors. I will start from the main board. What we are seeing here in this place is a channel simulation impedance module. There is a preamplifier to impedance channel, a signal from WBC channel and RBC channel is collecting here. This is a control part for motors, valves, pumps, and temperature place on the main board. A digital circuit includes processor and flash memory, PRP and AGB signal collecting here. External interface, it means other electronic components, other boards in this unit are connected in this place here. LAN and USB ports, this area. And debug interface, this is only for manufacturer. This one is not for you, it is not used by service. On this slide, you can see some important indicators on mainboard. What is important here? First, for LED should light continuously, and the next, this for first should light continuously with a green light, and the next 3 indicators are flashing during the analyzer operating. This is useful when some electronic problem appear in your analyzer. This is a photo of power supply. It is located at the top of the analyzer under top cover. The next board is a reagent detection board. What is the function? It collects signal from pressure sensors and photocouplers and transfer this data to mainboard. Reagent detection board, agent testing panel. Here is a picture of a board from both sides. This is the same part from both sides. The pressure sensors here. It collects a signal from the chambers, negative chamber and positive chamber. The next is indicator board. It is located behind the front panel. There is a buzzer installed in this place. Micro switch of aspiration button is connected here, and LED, and the LED from the front panel. When the analyzer is ready to use, ready to the cycle, they are green. When some error appears, they light with a red light. CRP laser drive panel. So it controls the laser signal in CRP channel and transfer this data to mainboard. And the last board, reagent refrigerator panel, it is responsible for control of the refrigeration system in the analyzer, like a Peltier fan. Here there is a Peltier control, fan control, and micro switch from the left door. So now I would like to speak about the maintenance. To keep the analyzer in good condition and obtain the correct result, it's very important from your side to perform maintenance correctly. So first you have find the information what maintenance should be done by user. And we have a daily maintenance. In case of daily maintenance, it is important to perform cleaner soaking every day and perform a normal shutdown. Don't switch off the analyzer without performing a normal shutdown. Very important to keep the analyzer in good condition. In weekly maintenance, it is recommended to perform swab cleaning manually. Swab is a part responsible for external cleaning of the needle. Also perform sample probe cleaning, external sample probe cleaning with also some cotton swab. And we suggest you to perform a cleaning of the box inside the analyzer. This is a box which chambers from impedance channel are installed here. And when you see some, if the customer sees some crystallizations in the area, should be cleaned by the customer. In monthly maintenance, it is recommended to check the floater status. especially for a waste floater. Check and clean if it is dirty. I don't think so if it is necessary to check the diluent float sensor, but maybe for the waste sensor it would be necessary. And check if the hemoglobin voltage is within correct range, 4.5 volts. If not, it is suggested to adjust to the correct value. In the table below, you can find information about service life of consumable parts. And first from the sample probe. Service life for the sample probe is around 50,000 samples. When the tip of the sample probe is worn, it should be replaced. For the cotton swab, the service life is 30,000 of samples. Actually, this is there is no O-ring inside, but the internal diameter could be worn by exceeded these values, and it should be checked by you and replaced if needed. Service life for isolation chamber is 1 year. Should be replaced during the yearly maintenance. And service life for the liquid pump. For the motor pump is 125 days of continuously work. And for the pump head is 460 days when this pump is working continuously. Maintenance which shall be done by service right now. During annual maintenance, we suggest you to lubricate mechanical moving parts. Also, I suggest you to check all syringes. The condition of the syringes is important. It is necessary to check if there is no leakage. If you see some crystals on syringe, it should be cleaned by you if needed. Checking the swab during the daily maintenance, if the internal diameter of the swab is worn, it should be replaced. During the yearly maintenance, you should also perform some cleaning cycle from the software, from the menu. Later, I will show you the software how to perform it. So this is all from maintenance from my side. Let's take a short break right now, and after the break, I will switch the camera to external one, and I will show you the screen with the menu of the analyzer. So let's take a short break. So let's continue the training. Right now you can see the main menu of the analyzer of this unit. So I start from sample analysis window. There is a main window where you can perform the analysis, and previous next you can switch the result previous and next, mode and ID. In this window you can select the mode which you want to use. There is possible to choose venous whole blood, capillary whole blood, and pre-dilution mode. And CBC plus 3D, that means only hematology part of unit working. CRP mode active, and both modules, hematology and CRP. Tap OK to apply the changes. Pre-entry options, what it means. You can input the patient data before you start the measurement. First name, last name, and the others. Validate option. You can use this option if you want to validate a result. You tap here, then you will see the message. Print, when you want to print the result. Patient info. So if the result is validated, you cannot modify the patient info. I will cancel the validation. And patient info, you can also input the patient data even after you finish the measurement cycle. Or if it is inputted previously, you can modify this data after the measurement is finished. But as you saw, this option is not active when the sample is validated. Custom parameters. You can add some off-system parameters to the software, and these parameters will be visible at the printout. You can add some off-system parameters to the printout. Also, it is possible to add some microscopic examination parameter. The result. You wanted to do some value, just choose the correct name and put the value. COM is not active because the instrument is not connected with LIS system. If it is connected, then you will see this option active. Actually, after the analysis is finished, the result is automatically sent to LIS, but it is still manually option visible for the sample in case you want to repeat the send to LIS. Edit result. It is possible to edit all the result with, you can input, edit and modify the result, input the value, the window, and press OK to apply changes. And if it is necessary, you want to delete the selected result. Then additional window appear and analyzer asks you about the confirmation. Review. Review means is our table. Is the table with all results from this unit. You can see sample ID, this place, mode, which was used to perform the analysis, and status. In status, we have 3 signs. The first is if it was sent to LIS system, if it was printed, and the third, if the result was validated or not. For example, you can choose the result and press validate the selected recalls. Then you will see some changes in place. You can also print the result from this menu, delete result, export result to USB stick, edit result, but not for validated result. And modify the patient info query. You can search the results from the history of this unit, for example, by name or by date. What we are seeing next, you can see the result as a graph with the histograms. You can also add some microscopic parameter. This is a similar option as in a sample analysis. And custom parameters of system parameters, which are measured not by the analyzer, but it is possible to add to the printout. It is not active because it is for LIS. Run chart. What is this option? If you select at least 3 results and press run chart, you can see something like a LJ graph for the all parameters. That means that option. CV, as I mentioned before, it is possible to perform a repeatability test. And if you measure 10, you perform 10 measurement, but could be less than 10 measurement, you can calculate the CV. For those 3 selected samples, the analyzer right now calculated CV values. for all those parameters, and for WBC is 1.6, for RBC 0.5, for hemoglobin 0.4. So this is it could be useful for you for the future. This is a way to perform the repeatability test and check the CV values. Research result. What is this? Is a window with the result in the table. You can print this result from this menu or send to LIS. So the QC mode, what we are seeing here. So in the QC settings, as I mentioned in the presentation, there is a module to input a new QC data into the analyzer. So when you press choose new button, you will see a table where you can input the data manually or use an import option, as I told you previously. It's possible to edit or delete or clear the result from this place. QC analysis. It is a window to perform the QC analysis. Before you start, ensure if correct file number is selected on this list. In my analyzer, in my unit, I have a low level of 3diff control on one under the file number 1. Number 2 is a normal label. Number 3 is a high level. And 4, 5, 6, there are my controls for CRP model. Label low for CRP, label normal for CRP, and label high. You can follow the results using a QC graph. You can check the tendency here. The same for all controls in your device. QC table, you will see the results in the table. Of course, you can delete, print, send to LIS, and export the file to USB stick. So next window is reagent management. And right now I will show you how input the new reagent into the device. So let's start from diluent. Select a diluent, just click setup, and you will see this kind of information. Place the RF card onto the card reader, and you have 30 seconds to do that. So I have a diluent card right now. And the message appeared. Diluent set successfully. So, and when you want to input new information about reagent, you have to perform this procedure for the whole reagent. After you input a new reagent, you will see the volume here is like for new reagent. Replace, that means analyzer will replace this reagent, replace all. The analyzer will prime it with all reagent. Purchase reminder, as I told you, it is possible to set purchase when you, for example, input 5 liter here, the analyzer will remind you when the diluent volume will be around 5 liter, and you will know if that it is necessary to purchase the order reagent. Exactly, end customer will know. So let's go to the main menu. This is a pre-dilution option. You can add diluent to the sample. If you want to use this option, just press the key. So we have an error with. I need to remove this error first. So after you input the information about new reagent, it is necessary to perform priming this reagent, because you will see an error in this place in this table. It will take a few minutes, not a long time. So it's finished. So when you want to use this option as diluent, so let's try. The analyzer is preparing to dispense diluent. So right now you have to input a vial to the sample probe and then press aspirate key to add diluent. Analyzer will automatically add diluent to your vial, and after that you have to dispense 20 microliter of blood to this dilution, and your sample is ready to perform a measurement in pre-dilution mode. So right now I am canceling this operation. So when your pre-dilution mode, the dilution sample is ready, you can analyze in pre-dilution mode. And then, as you can see, the pre-dilution mode is active only for hematology part of unit, not for CRP mode. It's not possible to perform pre-dilute sample in CRP mode. And after the cycle is finished, analyzer will give you a correct result in pre-dilution mode. So let's go to cal window. What we are seeing here, the manual, start from manual calibration. Manual calibration, you can manually change the calibration coefficient, this window. But it is not recommended by us. We recommend you to use a mid 3 CRP calibrator to perform this option, or to CRP channel, we suggest you to use 6 levels of calibrators. Calibrator, this is a calibration of 3D part of instrument. Right now I will repeat the same as I told you in the presentation. You need to perform at least 5 measurements, and then analyzer will calculate a new calibrator coefficient. Next, you have to save this data. Calibration with fresh blood. It is possible to calibrate the 3D part of instrument using fresh human blood, but it is a long process. It will take you a lot of time, because for each of sample you are seeing here, sample 1, 2, 3, 4, 5, for each sample it is necessary to perform at least 5 measurements to perform the calibration this way. Finally, you have to perform 25 analyses to perform this kind of calibration. So it is a long process. CRP calibration. Maybe I start from CRP gain calibration because it should be done first. This is a window to measure a blank sample. So you just need to press aspirate key 6 times and see if the conclusion is pass or fail. And CRP calibration with CRP calibrators. 6 levels of calibrators. Just input a target for each level from the assay sheets and perform at least 2 measurements for each calibrator. Then, only then, calculate button will be active. You want to calculate new calibration, just press calculate button and save apply changes. setup what is important here. So maybe I relog to service user because some additional options will be visible. To relog. So I am logging right now using service password M 06. So you can find this password in the user and service manual, I believe. So date and time is quite clear. Input settings, activate or enable or disable the soft keyboard. When you disable the soft keyboard, you should use external keyboard. Lab information. Okay. Agent settings. These settings, that means this is something like OEM settings. And this option is not this option is set by us, by manufacturer. You should not perform any changes in this window. Because if you change something, there could be a problem with your reagent card, with reading your reagent card. Reagent parameters. So you can modify the reagent names, only the names in this window. It's possible to modify diluent name, and then you will see the new name in, for example, not auto maintenance, but service. Replace reagent. In this place, you will see the new name of your reagents after you modified the name in this window. Auto maintenance settings. I was talking about in the presentation. I will skip this. Configuration of new user. You can add a new user with the password. Edit existing users or delete user account. Thermal printer settings. Actually, the density of for the thermal printer should be high because when you use the thermal printer, result the density is not enough. I suggest you to switch to the high, and then you will see the printout more clearly than, for example, for low density. Data. I was talking about in the presentation, so I will skip this. Parameter unit. Also, you can modify the unit which you want to use. Reference range, microscopic param, custom param. You can modify or add new custom parameter. This is something like offset parameters. The analyzer couldn't measure this parameter, of course, but it is possible to add the result to the printout for the patient. Characteristic parameters, what it means. It should be not changed by you. It is set by us. This is settings for the threshold. This is threshold settings for mid-sized cells area on the histogram. It can be modified, but generally it is set by us, and we don't recommend to change by you. In settings, we have a window where we can perform calibration for hemoglobin blank voltage and ERP scattering blank voltage. The correct range, the correct value from the hemoglobin is 4.5 plus minus 0.3 volts, and correct value for scattering blank voltage is 0. 0 plus minus 0.3 volts. So actually right now all values are within the range. Flag. As I told you before on the presentation, there is a possibility to modify the flag rules. For example, leukopenia, and it modify this value. Actually, we also do not suggest to. We don't recommend you to change it but of course some customers has some expectations from this side, and it is possible, but we do not suggest to change. Suspicious armor. There is a settings which also we don't recommend you to change. It's set by a manufacturer. Communicate, host, and LIS. These are settings related with connection to LIS system. Debug settings. Debug settings. This is the kind of data which can be saved by analysis performing in the software. And after the analysis performing, you can export this data, export this service log to USB stick. And this service log will include this kind of information as which are enabled in this window. If you select all these options, the analyzer, the CSV file with the single result of sample will include more data, more information to check by service or by us. Print settings. So this one is clear. I repeat one thing. If you use an external printer, the printer driver should be checked automatically. When you want to use from thermal printer, just use the thermal printer. For the external printer, choose check automatically, and when you connect the printer by USB cable, the analyzer will automatically find the correct driver. But we suggest you to use PCL3 or PCL6 drivers. Patient information. You can modify what type of patient information do you want to collect. Auxiliary settings. Sample ID entry method can be set as auto increment or manual entry, depend on you. So let's go to the service options. Now the English, you can change the language here. We have Chinese, Francois, Russian, Portuguese, Spanish, and German. So let's go to the service options right now. What we are seeing here. Replace reagent, clean. You can perform cleaning like you see in this window, WBC, buff RBC, sample probe, CRP, and CRP reagent tube. Maintain. You can perform unclogging the aperture. You can perform cleaner soak. Actually, what is the difference between this option and the clean option? For the clean option, analyzer doesn't require the cleaner. This kind of cleanings are performed with diluent. And this kind of cleaning you are seeing here requires a cleaner to the needle. And then analyzer will aspirate by sample probe and transfer the cleaner to the correct place. So it is possible to perform unclogging the aperture, zap apertures when this is clogged. You can perform cleaner soaking. Cleaner soaking, this whole device is soaking with cleaner. This option is only for WBC chamber, cleaner soaking for RBC, and for CRP. And from my side, I suggest to perform you this option, this cleaning at least half an hour every 6 months, because it would be useful to keep this analyzer in good conditions. So you can also empty WBC, empty RBC in case of, I don't know, replacement or just checking something. Empty RBC and empty heating tank. Comprehensive device, what it means. Here you can perform the fluidic initialization when your background is not in the correct range. It is necessary to prime fluidic again, and perform fluidic initialization. So this is the option to do in this window. You can also perform clean fluidics option, empty fluidics from the reagents, from the liquids, and prepare to ship. That means this is the whole procedure. First, the analyzer will tell you to remove the tube from the bottles, then connect the distilled water. The analyzer is performing rinsing with the distilled water, and in the end, analyzer will tell you that remove the tube from distilled water, and analyzer will prime with the air and will be ready for shipment. So next, self-test. You can perform a self-test of the mechanical. This is a checking of the mechanical part of syringes, motors, for example, sampling syringe self-test. After finished, you will see the message in this window, if it is normal or failed. The same for other. This is just a checking mechanical part of the syringe. I mean motors. Analyzer checks if the movement of the motors and the holder of the syringe is working correctly. This is just a checking mechanical part of the syringe. Pressure self-test. It is possible. This is actually important for us for service. It is possible to perform a pressure test and vacuum test. You tap pressure. Analyzer is performing pressure self-test. And after finish it, you will see the result. You will see a message. You will see the below message appear. If something is wrong, if the value is not in the correct range, you will see an alarm in place. The same for the vacuum. Actually, this is a short process, but it could be useful for you. So let's continue. Valve pump self-test. You can turn on and turn off each valves and check if the electrical part of valve is working correctly. Of course, if the electrical part of valve is working correctly, that does not mean that the valve is working correctly. Of course, pump number one is a liquid pump, and the second pump, the air pump. This one, the second pump works really quiet. It's hard to hear. So in the service menu, we can check the temperature status. Of course, all these temperatures should be within the correct range. If one of these values exceeded, you will see an alarm. Voltage current checking. Similar procedure for voltage and current should be within correct range. Sensor. In this window, you can see the sensor status of all photocouplers from the mechanical parts. Reagent photocouplers and from the mechanical part of the analyzer, and reading from the micro switch, because on the right side there is a micro switch of the door, and also there is a micro switch of reagent. For example, right now I am opening the refrigerator door, and like you see on the screen, the error appear. So after that, you should tab error and press remove. Actually, when you open the left door, the refrigerator door, after you close it again and tap remove error, analyzer will automatically prime with the reagent line in CRP module, because it analyzer assumed that someone could replace the reagent. So it's ready. Let's continue. Counter. This is a counter status. How many samples was performed, QC, calibration. You can see the details here. Which mode, which blood type, so on. Disk info. So we have a status of internal memory and SD card. There is a SD card inside of this instrument, which all data are stored. Log. This is a service log from the analyzer. Logs and errors. What I want to show you in this menu, so temperature curve. X3, this is an option in the menu to calibrate the sensors, the temperature sensors. But it is not necessary to use it. Actually, it is possible in this software, but we don't recommend to use it. It is necessary to have real sensitive sensors, and then you can verify the temperature. But normally, it is not necessary to adjust it. This is just an option in a service menu. But when we go to gain cal, here, what it means. It means this is something like a calibration of impedance channel. And if you see MCV, this is not about MCV in a red blood cells channel, but it means the latex particles MCV. And as I told you, this is something like a calibration of impedance channel. Normally, it is not necessary to do that. It is done by the manufacturer, but for the future, in the future, we will have a calibrator to perform this pressure. But don't worry, during the installation, your analyzer is ready, is calibrated. But right now we are working on the calibrator, which allows us to perform all calibration to impedance channel. And this is just an option to perform it, but it is not necessary to do it during the installation. Position adjustment. This is the adjustment of the tip of the needle, as I mentioned in the presentation. So when you want to check the position, just press check. So right now in the right door is the end of the needle. If not, you need to use start button and performing the adjustment. But normally it is not necessary to do that. Pressure car. Pressure car, it is possible to check the pressure and calibrate the sensor pressure. But actually, we don't know how to use this tool for now. And it is also not necessary to do that by you. Toolbox. You can send a ping if there are some connection. There is some connection problem with LIS system. Okay, let's continue. I have heard there was some problem with the connection from my side again. Sorry for that. Service log. Yeah, it's possible to send a service log to USB stick. When the USB stick is not connected, you will see this kind of message. Oh, I forgot to show you. This is very useful function. It is possible to measure aperture voltage in WBC and RBC channel by analyzer. And for example, for WBC, this is a quick process. Currently, the voltage for WBC aperture is 1.78 volts. Below, you can see the target, the range of the voltage. If the voltage is exceeded, for example, more than 2 volts, that means that your aperture could be clogged or dirty. And when the voltage is less than 1.45 volts, that means could be some electrical problem in the channel, the WBC channel, or problem with the chamber, or the cable, maybe some interferences. And so that please note, it is very important, the correct value, correct voltage value for WBC chamber is around 1.8 volts. For the RBC aperture, is a little bit lower. It's something like 1.9 or 2 volts. 2 volts is okay. Even 2.1 is okay. But if the voltage is exceeded above the 2.25 volts, that means there's something wrong with your aperture, with your chamber. The aperture also could be clogged or dirty. When the value is less than 1.65 volts, that means you have some electrical problem in impedance channel, in RBC chamber. And in this window, you can see some other useful tests for RFID card. You can check your RFID card, for example, the diluent card. Yeah. And right now you can see the result of this test. That was for this card, which was used by me before today. So this card was previously used by me, and you can see this information on the result that this card was used. For example, let's check another card for lice. I tap here and put to the reader. So there is an information that it was not used before. So you can verify if your card was used or not before. Sometimes it can be useful. The other information like reagent name, type of the bottle, volume of the bottle, and expiry date will appear on this result. So what kind of other tools we have? Data cleanup. You can clean the all data from the software. You can cancel all the information. You can check the version, currently version of your analyzer. You can export this data and upgrade. You can perform software upgrade using this tool, upgrade. So you need to connect the USB stick with upgrade file in the main catalog. Then analyzer will see this kind of file to performing upgrade. So just if you want to upgrade, just select the correct file and press yes. As I mentioned before, there is no version and there is no latest version on our website, but in the future, we will share you the latest version if it will be released. So this is all from my side, from the analyzer. The menu is not complicated as you can see. There are a few options, but not all is necessary. So this is all from my side for today. Thank you for your attention. Thank you for your time. If you have any technical question, you can ask using over the WhatsApp. I would like to inform you that this recording, this video from this training will be available under this link for the next few days. So you can return to the recordings if you need it. And this is all from my side. After the training today, maybe tomorrow, I will send you a link to the test, and when you complete this test with positive result, then you will receive a certificate from this unit. So thank you for your attention once again. I hope this training will be very useful for you. If you need anything, please ask a question over the WhatsApp channel. So thank you once again. Have a nice day. See you next time, and bye. Kosmos, kosmos. Dobrze ci poszło, Marek. Zresztą nie szkoliłem, ja. Tam miało co innego powiedzieć, że
We see ourselves as a lifeline which connects doctors, diagnosticians, and patients with cutting-edge IVD technology. We provide medical solutions to make your healthcare better. It all started in 1985 in Poland when Korme had its beginning. Since then we have been striving for a better, healthier world. Next, in 2001, Orphe joined the world providing advanced hematology equipment. In 2005, two brilliant teams became one, like two rays of light focused on one lens. Over the years we have helped more and more people throughout all the world with the access to reliable tests and high-performance IVD technology. We refreshed our brands to emphasize our common goal. We are constantly expanding our portfolio to help you with a wider range of challenges. We help doctors, lab technicians, IVD experts and foremost, patients, to deliver positive health outcome. All of that led us to become one. Korme Diagnostics. The lifeline to